Hello, welcome to this video. This is about quadratic discriminants, and we're going to start off by doing some examples of different types of quadratic equations where we will solve it using the quadratic formula. And then after I'm done with all those three examples, I'm going to show you in each individual one what exactly it will look like. Yeah. So we start off with this x squared plus 2x minus 4. In this a is 1, b is 2, and c is negative 4. And we can write our quadratic formula, which is negative b plus minus square root b squared minus 4ac all over 2a, where your b is negative 2, so negative 2 plus minus square root of 2 squared, which is 4, minus 4 times 1 times negative 4. That all over 2 times 1. Okay? And this will give us negative 2 plus minus square root of 4 plus 16, which is 20, all over 2. And at the end we get x equals negative 1 plus root 5 and negative 1 minus root 5. Okay, so we got two values because this thing was negative 2 plus minus square root of 20 over 2. Now I want to also sketch the graph, and I want to label the intercepts as well. So for this one, we know that the 2 points at which it intersects the x-axis is negative 1 minus root 5 and negative 1 plus root 5, right? And right in between both of them will be its vertex, and your y-intercept is negative 4. So it will look something like this. Okay, right, and it goes up to the top. Now that's the first example, right, where it will look something like this. The second example, x squared minus 6x plus 9, I'm going to solve that as well the same way. So negative 6 plus minus square root of negative 6 squared minus 4, 1, 9, all over 2 times 1. And that's going to give me 6 plus minus square root of 0 all over 2, which is going to give me 6 plus 0, 6 minus 0, 0 doesn't have a plus and minus value. And so we're just going to have 6 over 2, which is just 3. And therefore, the graph here, it looks something like this. The y-intercept is at 9, and the root is at 3. So it looks something like this. Whereas you can see the turning point is at the root. Okay? And if you see, there is a huge difference between the two, where if you see the second one, there is a part of the curve that's under the x-axis, while here the vertex is at the x-axis, right? Now one last example, x squared minus 2x plus 3, again the same thing. We'll do the same thing with this as well, where negative 2 plus minus square root of negative 2 squared minus 4, 1, 3, all over 2 times 1. This is going to give me 2 plus minus square root of negative 8 over 2. And as you know, you can't square root a negative 8. So you can't square root any negative number. And so negative 8 is not square rootable. And so this is not going to have any values, right? There's not going to be any answers for this. And if you draw this graph, try to draw this graph using the completing the square method, you'll end up with something like this. Okay? Where it never really touches the x-axis. And we know that also using this because there is no value for x. Because we know if we do have a value for x, that value of x is when it touches the x-axis, right? And so we have three different cases here where now we end up talking about the discriminant. One of them had, for the first example, it was root 20. The second example, it was root of 0. The third example, it was root of negative 8. And that's where the difference lies. That's where the difference is when it comes to how the graph looks like. For any positive value under the square root, you will get two roots, meaning it will touch twice. You'll have a positive and a negative root. Whenever the square root is 0, you don't have a positive and negative. And so your root, your x-intercept, is actually just your vertex. And in the last case where your square root has a negative value, it never touches the x-axis, right? And we can simplify this into just whatever is inside the square root, which is the b squared minus 4ac. And that thing is known as the discriminant. We can set conditions on it, and if those conditions are met, the graph will look like one of these three. So if b squared minus 4ac is greater than 0, like the example 1, you're going to have two roots. If b squared minus 4ac is equal to 0, meaning there's no plus or minus root value, you're going to have one root. Yeah? Or you can have two repeated roots, two equal roots, meaning they are the same, which means you have one root. And the last case is if your b squared minus 4ac is less than 0, where you're going to get a negative square root, which is impossible. And so you're going to have no roots. Here are some of the questions where you apply the discriminant. For example, find the values of k for which x squared minus 5x plus 9 equals to k times 5 minus x has two equal roots. So we know about two equal roots, meaning b squared minus 4ac is going to be equal to 0. But at the moment, we have this right here. The way we do it is we would want to equate it to 0. And then we can apply our b squared minus 4ac depending on what it looks like after we equate it to 0. So firstly, as everybody would do here, is expand the brackets. So x squared minus 5x plus 9 equals to 5k minus kx. Then we can equate it to 0, where take 5k and negative kx to the other side. You get x squared minus 5x plus kx plus 9 minus 5k equals 0. We can rewrite this x squared plus x, k minus 5 plus 9 minus 5k equals 0. And we can see from here our a is 1, our b is k minus 5, and our c is 9 minus 5k. Then we can write this into our b squared minus 4ac formula. b squared minus 4ac, and we want it to equate to 0 because of the fact that it has two equal roots. And so we're going to get k minus 5 squared minus 4, 1, 9 minus 5, k. And expanding this, you get k squared minus 10k plus 25. And expanding this, we get minus 36 minus 20k. That's equal to 0 because we made b squared minus 4ac equal to 0. Okay? And then from here, we get k squared minus 10k plus 25 minus 36 plus 20k. And at the end, we get k squared minus 10k plus 20k is plus 10k minus 11 equals to 0. And basically, this would give us the values of k for which this the b squared minus 4ac is equal to 0. So we can solve this quadratic equation by factorization. K plus 11, k minus 1 equals 0. And this will give us k equals negative 11 and k equals 1. And those are going to be your two values for k. Okay? And so for these two values of k in this original equation, you will get one equal root, or you will get one answer for your quadratic formula, right? So if you use this k and then you solve that quadratic equation, you're just going to get one value. Let's do another example where we're looking at two distinct roots instead. We're here the same thing, kx squared minus 2kx plus 8 equals 0. And two distinct roots, meaning two different roots. B squared minus 4ac, you want it to be greater than 0, right? Because the square root should be positive. And so we get a positive and a negative value, right? Here your a is k, your b is negative 2k, your c is 8. And you can do this now. So b squared minus 4ac greater than 0. My b is negative 2k squared minus 4, k 8 greater than 0. And we can expand, so 4k squared minus 4 times k times 8, which is minus 32k greater than 0. And this one will just give us 4k, k minus 8 equals to, remember how we solve inequalities from one of our previous videos? We would equate it to 0, find our values, k equals 0 and k equals 8. Then we can draw your graph. So it will look something like this. K equals 0 and k equals 8. 8 and, sorry, 8 and 0, and we want it to be greater than 0. So we want to have this part right here and this part right here. That means we want our k to be greater than 8 and our k to be less than 0. And those two are going to be our values of k for which you would get two distinct roots. Okay? Now, a bit more explanations on the discriminant, more specifically how they would ask you in your Cambridge exams. There are three solutions really when you're looking at simultaneous equations. Now remember, the first topic that we did was simultaneous, where we said that if there are two equations that are together, and when we equate the y's together, we will get the points of intersection of them, right? And we can use that information with the discriminant to find specific use cases of that intersection, right? So if you have two equations, suppose y equals to f of x and y equals to g of x, and we equate them together as we would do in a simultaneous equation. G of x equals f of x, and as per what we've done before, we would first equate this to 0. So f of x minus g of x equals to 0. Then on whatever we have on the left, we could apply b squared minus 4ac and make it greater than, equal to, or less than 0, depending on what the question is telling us. So if it gives us a hint that you want 2 points of intersection, then you're going to make b squared minus 4ac greater than 0. Yeah. If you get a hint that they're telling you 1 point of intersection, then you're going to do b squared minus 4ac equals to 0. And if you see that they're giving a hint of they never intersect, then you're going to use b squared minus 4ac less than 0, right? There's going to be no point of intersection. And these are the specific use cases, the application part that they ask for in the question. This is very important right here, wherever they ask a lot where one line is a tangent to a curve, and so you need to equate them, because remember, tangents usually intersect with the curve, and they intersect at only 1 point, which is perfectly the definition of your discriminant equaling 0. Okay, so these are some important points that you should look at and identify whenever you get a question of a similar way, right? Okay, let's look at these questions now. The applications of the discriminant. Find the value of k for which y equals to x plus k, which is a line, is a tangent, meaning it intersects only once, yeah, to the curve of x squared plus 5x plus 2. So we have y equals to x plus k, and we have y equals to x squared plus 5x plus 2. And remember, because they intersect, you can solve them simultaneously. And so we can put the y's together, and we'll get x plus k equals to x squared plus 5x plus 2. Then the next step obviously always is equating it to 0. So x squared plus 5x minus x, because you're taking this to the other side, it's plus 4x, then plus 2 minus k equals 0. You equated it to 0, where your a is 1, your b is 4, and your c is 2 minus k. And then, as we know it intersects only once, we can say that our b squared minus 4ac is going to be equal to 0. And we can solve it accordingly. So 4 squared minus 4, 1, 2 minus k equals to 0, which is going to be 16 minus 8 plus 4k equals to 0, which is going to give you 8 plus 4k equals to 0. And we can solve for k here. K will be negative 2. That means when k is negative 2, when this k is going to be negative 2, this line right here is going to be a tangent to this curve. Okay? Next part. Find the set of values of k for which y equals to kx minus 1 intersects the curve y equals to x squared minus 2x at two distinct points. So looking at this, we should know straight away that b squared minus 4ac is greater than 0, and we can continue from there. So we have that these two are intersecting. That means you can simultaneous them. So kx minus 1 equals to x squared minus 2x. Then obviously you would equate them to 0 then. So x squared minus 2x minus kx plus 1 equals 0. Then we can rewrite them. So x squared plus x negative 2 minus k plus 1 equals 0. And we can a equals 1, b equals negative 2 minus k, and c equals 1. where here we want b squared minus 4ac to be greater than 0. So negative 2 minus k squared minus 4, 1, 1 greater than 0. And you expand this, you get 4 plus 4k plus k squared minus 4 greater than 0. These two cancel out. We get k squared plus 4k greater than 0, where we can factorize k plus 4. And if you want to solve an inequality, you first equate it to 0. You get k equals 0 and k equals negative 4. Then we can draw that on our curve. It's going to look something like this, where this is 0 and this is negative 4. Then we want it to be greater than 0, so we are looking at this part and this part. And so we want the fact that k is less than negative 4, or that k is greater than 0. And these are going to be the set of values for which this line would intersect this curve at two distinct points, meaning they're going to have 2 points of intersection. Okay. Finally, one more use case where this line right here does not intersect with this curve right here. Now, these are weirder curves, but it's the same concept. You have to simultaneous them. Where, remember, when you're simultaneousing, we talked about this in our first video, where you want to make them into explicit form, meaning make one of them the subject. We could make y the subject because that's the thing that we usually use. So we can make y the subject here. Y equals to k minus 2x. And this one right here, xy equals to 8. Y will equal to 8 over x. Then again, we can equate them to each other because you want to check if they are intersecting. So we are looking at the case of intersection. And 8 over x equals to k minus 2x. K minus 2x. And we can equate it to 0, but obviously we want everything to go to the top. So we multiply by x on both sides. And on the left, we get 8 equals to kx minus 2x squared. Then we do it normally. We equate it to 0. So 2x squared minus kx plus 8 equals to 0. And we have equated it to 0. Now we want to find the fact that b squared minus 4ac is less than 0. Okay, so we want to find that because you don't want it to intersect, which is the case of b squared minus 4ac less than 0. And here our b is negative k, a is 2, b is negative k, c is 8. So negative k squared minus 4, 2, 8, less than 0. K squared minus 64, less than 0. And you want to solve that. Again, same thing. We equate it to 0 first. K squared equals to 64. And we can square root. We get k equals to plus 8 and k equals to minus 8. And again, we draw it on our graph and see what values we need. Minus 8, plus 8. And we need the values that are less than 0, which is going to be this middle section right here. And this middle section are the values between negative 8 and positive 8. So 8 is 8 greater than, negative 8 less than k, which is less than 8. And those are going to be the set of values for k, for which these two, this equation and this line will not intersect using the discriminant. So this video showed you a lot about how to use the discriminants for different types of questions, and that's how we do it in a nutshell. Now, quick summary of everything we have done up to now, all the 3 videos for quadratics. Firstly, you should know that quadratic equations can be solved by factorization, completing the square, and quadratic formula. Okay, and then solving simultaneous equation, you need to make it into explicit form, meaning making either y or x the subject, and then substituting one to the other. We try not to use elimination unless it's both of them are linear, which you don't get in this level. So most of your questions will be solved by substitution. Then for maximum and minimum points and the lines of symmetry, we can write it into the completing the square formula, where we get it into this format of some sort. And our line of symmetry is at the vertex where x is equal to, so x minus h, we equate it to 0 and we solve for that. So x equal to h. At that point, we have our line of symmetry. Okay, Or if you want to have line of symmetry from the original equation, we can just do negative b over 2a, okay, to get our line of symmetry. If a is greater than 0, so if a is positive, then we have a positive quadratic, and so we have a minimum point. At where? At this x equals h and y equals k. So at the coordinates h, k. And if a is less than 0, meaning it's going to be a negative quadratic, then we're going to have a maximum. Yeah, because it's going to be a U curve. This is a negative quadratic, and this is going to be a positive quadratic. Okay. Then when you're looking at the discriminant, if b squared minus 4ac is greater than 0, we have two roots, meaning two intersection points. If b squared minus 4ac is equal to 0, then we have two equal roots or one root. And if b squared minus 4ac is less than 0, then we have no roots. Okay? And the condition for a quadratic equation to have a root, meaning to have at least one point of intersection, we look at these two cases together. The one where it has two distinct or one root. So we're going to make it greater or equal to 0 instead. Then if you want to see how points intersect, we can look at two lines where we use the simultaneous part first. So we arrange the linear equation to make either x or y, then we substitute it into the other, and we write it into some form of a quadratic equated to 0. Yeah. And then we can use our b squared minus 4ac in order to find what we want. So if it's a tangent, remember, then we use b squared minus 4ac is equal to 0 after you equate it to 0 after the substitutions. And if you want 2 points of intersection, then b squared minus 4ac is greater than 0. And finally, if you want no points of intersection, meaning the two lines, the line and the curve do not meet at all, then you want your b squared minus 4ac is less than 0. And with that, we're done with the quadratic section. And our next topic will be functions.